All right. So now we are going to talk about inverse element. All right. Inverse element. Now, before we define it, I want to show you something. Of course, you already know that identity element, we define it this way, that whenever it's added to any element, it has no effect. All right. Now, assuming that 2 is an element and there is another element, let me say minus 2. So let me say we added these two. If we add these two, it will be 2 plus times minus is minus, so 2 minus 2 is 0. You can see that this was added to this under addition operation and it gave us what? 0. And 0 is what? Is a neutral element under addition operation. All right. So now what can we say that this is? Of course, for you to combine a certain element with another element and it gives you a neutral element, then we say that each one is an inverse to each other. All right. So let me further my example, like 3 plus negative 3, which is 0. 4 plus negative 4, which is 0. Let's try it on the case of multiplication. So if you have something like, let me say, 3 times 1 over 3, or 3 raised to the power minus 1. So what will it going to give us? Of course, 3 times 3 raised to the power minus 1. According to indices, anything raised to the power minus 1 is 1 over that thing. X raised to the power minus 1 is 1 over x. So 3 times 3 raised to the power minus 1 should be 1 over 3. All right. So we can do this over 1. We can say 3 here, 1, 3 here, 1. 1 times 1 is 1 over 1 times 1 is 1. So which is what? 1. So of course, 3 times 3 raised to the power minus 1 should give you 1. All right. Okay. From that, if we, all right, excuse me. Okay. So from this activity, we can extend this to 4 times 4 raised to the power minus 1, which will give us 4 times 1 over 4, which is 1. 5 times 4 raised to the power 5 raised to the power minus 1, this will give us 5 times 1 over 5, which is 5 over 5, which is 1. Then you can see that in multiplication, the neutral element is 1. So if two elements multiply itself and give you the neutral element, then 1 is an inverse of the other. In fact, 1 is exactly opposite of the other. So when two opposite things meet together, they give you a neutral value. All right. When two opposite things meet together, they give you what? A neutral value. So you can see that multiplication is a neutral element under, you can see that 1 is a neutral element under multiplication what? Operation. And two elements combine each other to give you 1, meaning that 1 is an opposite of the other. All right. So if x is an element and I combine it with x to the prime, that is, I don't necessarily mean 1 by this. I just want to differentiate. I just want to use this to differentiate it from x, and it happens to give us e. Then we can say that this is an inverse of this, or this is also inverse of this. So both of them are inverse of each other. So what I'm trying to say is that whenever two elements combine together under a certain operation and they give you e, which is an identity element or neutral element, then 1 is an inverse of the other. All right. 1 is an inverse of the other. So negative 2 is an inverse of 2 under addition operation. So 3 raised to the power minus 1 is an inverse of 3 under multiplication operation. Why? Because they give you the result of their neutral element or identity element under that what? Operation. All right. So can we go and define what the inverse element? So definition: let X be a non-empty set which is closed under a binary operation. Asterisk. All right. Now, if for all x in the set there exists x prime, which is also in x, such that s combined with that particular element in x, you can call it x prime. All right. And there happens to be commutative, that is their order of combination is immaterial, and there happens to give you e, if this exists, we can say it's an inverse of x. All right. So if x prime exists in x, it is always what? Unique. All right, it is always unique. Now the emphasis I want to lay here is it's not necessarily about the commutativity. You know what I mean by commutativity? The order of arrangement is not important. The order is immaterial. That is, x combined with x prime is something as x prime combined with x. So the order is important. So whether if x started first before the other one, any so far that one is an inverse of the other, once they combine, they will always give you the neutral element, meaning that an element and its inverse under a certain operation is neutral. That is, when they combine, they will give you a neutral value, showing that they have nothing in common. All right, they are exactly opposite of what? Each other. They are exactly what? Opposite of each other. So they will always give you what? A neutral value. Just have this in your score, that whenever an element combined with its inverse under a certain operation, the result will always be what? A neutral element, or identity what? Element. All right. So in a nutshell, the summary of all these things is that if x is a certain element under a certain operation, whenever it's combined with its inverse, maybe at this point I will start using x raised to power minus 1 as an inverse. Now this x raised to power minus 1 does not necessarily mean 1 over x, which we always know it to be. It's just a symbol of representing the inverse of x. It will always give us what? E, where E is what? Where E is identity element. So this is the actual definition of inverse element, where E equals to identity element, and s is an x to the negative 1 is the inverse of x. So whenever anything combined with its inverse, any element combined with its inverse under a certain operation, it will always give you an identity or neutral element. So have it in mind. Now, even s is also inverse of this. All right. Forget the fact that we are taking this as the inverse of x, but also s is also inverse of its inverse. All right. So let's take an example here. So what did it say? So it says a binary operation, this defined on the set of integers such that, all right, solution, such that m combined with n will always give us m plus n plus mn for all what? For all integer m and n. So m and n are coming from what? Integer. Right? So they say if the identity element is 0. So they have already given us the value of identity element. They have already given us E as 0, right? So they ask us to find if identity element is 0. Okay, sorry. So combine with m and n, which is m plus n plus mn for all integers m and n. Find the inverse of -5 under this operation if the identity element is 0. So the identity element is 0. Now we will not start finding the inverse element of 5. First of all, we are going to choose an element and then find the inverse. We need to find the general equation of the inverse element. All right. So we can pick either m and find the inverse of m. We can pick either n and find the inverse of n. Later we'll replace it with -5. All right, so let's get started. So we are going to choose whether if it is m, we are finding the inverse, because what m represents in this case, n also represents. M simply means any integer, and n simply means any integer. All right, so both m and n represent almost the same thing. Okay, so we can say let m inverse, which is also in z is what? Set of integer. Let m inverse be the inverse of m. We are choosing m here. We can also choose n. Anyone is acceptable. So if m is the inverse of this, so therefore definition, what's the definition of inverse element? That whenever an element combined with its inverse, under any what? Operation. So this combined with its inverse, the result will always be what? Neutral element, meaning that any element combined with its inverse under a certain operation is neutral. is identity. All right. So from here we'll get our first equation. So therefore we have that M combined with M inverse equals to E. What is our E? Our E is 0, 0. So equation 1. So now in the in identity element case, we always have two equations. Likewise in what? Inverse element. So in inverse element we also have two equations. One equation, first equation is from the definition of what? Inverse element. The second equation is general equation. So we are going to redefine this in the general equation. If we redefine this in general equation, say our M remains M, but our N has changed to what? M raised to power minus 1. So let's interchange them. So therefore, we're going to say also M operation, M inverse from general definition is going to be the first plus the second. Our second here is what? M raised to power minus 1. Then plus the first, which is M multiplied by the second, which is M raised to power minus 1. So this will become equation 2. Now the same result in the equation 1 give us 0. M combined with its inverse 0 and M combined with its inverse equals to this. Now difference between the two is that the first one is definition of what? Inverse element, and the second one is the general definition in the equation. So can we compare the two? So comparing equation 1 and 2, rather this is equals to this. So therefore 0 is equals to what? M plus M inverse, then plus M inverse. All right. So remember, we are making the M inverse the subject. We're making the M the M inverse the subject of the formula because that's what we are looking for. We're looking for inverse of any element. Remember, M is any integer or any element in Z. All right. So how can we do that? Of course, we can remove M from both sides because M is alone here. So if we remove M from both sides, we have that. We'll subtract M from both sides. We have 0 minus M equals M plus M inverse plus M inverse minus M. So that M cancel M. So I left with 0 minus M is still minus M, which is equals to M inverse plus M inverse. So we factorize M inverse in these two cases. Factorize completely. So I have that minus M is equals to factorizing M inverse. M inverse divide itself. Anything divide itself is what? 1 plus M inverse cancel M inverse remaining what? M. Alright. So in this case, we are going to remove 1 plus M by dividing both sides by 1 plus M because it's multiplying M inverse. Now to understand better about this equation, watch my videos on equation. So if we divide both sides by M plus 1 plus M, so we have that negative M over 1 plus M is equals to M inverse then 1 plus M all over 1 plus M. So the 1 plus M cancel out with 1 plus M. So therefore, this negative can come here. So therefore, we have that our M inverse is equals to this. What is here? Minus M over 1 plus M. That is the definition of the inverse element. So any element M, its inverse, so inverse of any element should be minus of that element over 1 plus that element. So here, they are asked us to find the inverse of minus 5. So here, the element we are looking for at this moment is what? 5. So we're going to substitute M, sorry, not 5, negative 5. We're going to substitute M with what? Negative 5. All right. Now remember that this is general definition of the inverse element under this operation. All right. So we are going to substitute negative 5. So we find the inverse of negative 5. And the inverse of negative 5 is going to look like this. So therefore, negative 5 inverse. So we are now calling our M. Our M is now becoming negative 5. All right, because we are asked to find the negative 5 and inverse of negative 5. So this will be equals to minus the negative 5. Wherever you see M, you put negative 5. All right, all over 1 plus negative 5, which is equals to minus is plus, which is 5 all over 1 plus. Plus minus is what? Sorry, this is 1. Plus times minus is minus 5. So this is going to be equals to 5 over 1 minus 5 is what? Minus 4. All right. So in this case, we can take the minus up. If we do that, it will be minus 5 over 4. All right, which is equals to, now we have taken the minus up, right? So which is 5 over 4. So at this point, this is improper fraction. All right, so we can put it to mixed fraction, which is 1 whole number 1 over 4. All right, to understand better, if you are not convenient, if you don't understand the solvings, You have to watch my videos on simplification of fractions and all of that. All right. So that is it. Is the answer on the option? Yeah, of course. -5/4. That is A. Okay, so we go over to the next question. What does the next question say? Next question says, question number 2. So a binary operation, this is defined on a set of real numbers by, so this defined on a set of real numbers. So whenever two real numbers combine to give us the product of the 2 divided by 6 for all what? Two real numbers. Like for all x, y, which is a set of real numbers. So they asked us to find the value or the inverse of 20 under this operation when the identity element is 6. So they have given us E as 6. So we can say we can pick anyone. All right, we can pick anyone to be our inverse element. We can find inverse of x or inverse of y. What x represent, y also represent, because all of them are what? Real numbers. So we can say let x inverse, which is also in R, be the inverse of x. So from definition, therefore s combined with its inverse under this operation, it will give us E, right? That is from definition. All right, from definition of inverse element. So therefore, we have that x operation, its inverse is going to be E. What is our E? 6. So I'll call this equation 1. So our equation 2 will be from the general equation, but we are going to use this to redefine it in the general equation. S remains x, but x inverse is y here. So any two elements combined is going to product of the 2 divided by 6. So s combined with its inverse is going to be product of the 2, which is x times x inverse, x times x inverse, then divided by 6. All right. So if we solve, okay, this is our equation 2. So we are going to compare the two equations. All right. If the same thing give you different result, then different results are equal. So 6 is equals to this. So therefore we have that 6 is equals to x inverse over 6. Of course, we multiply both sides by 6. So we have 6 times 6 equals x inverse over 6 times 6. So that 6 cancels 6. 6 times 6 is what? That is 6 equals x inverse. So we're looking for x inverse. So therefore we divide both sides by x. So which is now 36 divided by x equals to x inverse divided by x. So that x cancel out with x. So therefore our x inverse is now equals to what? 36 over x. So this is our formula for the inverse element. All right. So with this we can find the inverse of 20. Right here our x is what? 20. All right. So therefore the inverse of 20. Therefore 20 inverse is going to be 36 over what? 20. So what is common? Of course, 4 is common. 4 here, 5. 4 here, 9. So it's going to be 9 over 5, or one whole number. Yeah, 4 over 5. One number 4 over 5, or 9 over 5. So our answer here is C. So thank you very much. And our next class, I will give you assignment, all right? So make sure you participate in that assignment. God bless you.